Hello, amazing students. We're going to complete section 5.2.2, how do arithmetic sequences work? Remember, we're trying to differentiate between arithmetic sequences and geometric sequences. Do you remember the difference between the two? Right. What letter does arithmetic start with? It starts with the letter A, so we can remember that arithmetic would mean addition. While geometric, of course, has to be the other one, which is a multiplication pattern. Okay, so take a few moments to write down these notes under section 5.2 vocabulary. We'll pause the video here so you can take some notes. All right, so hopefully you have everything written down for this. There's a couple of things that I do want to point out for these notes. It is that the initial value really isn't something that matters too much. Actually, the internet believes that initial value is the first term in the sequence, while other people believe that the initial value is the zeroth term in the sequence, which is the number before the first term. So we typically don't want to work with the initial value too much. The initial value helps us get the previous term. For example, we have a list of numbers such as 7, 10, 13, 16. And pretty quickly you can recognize the pattern, right? If I asked you what is the next number in that sequence, what would you say? You'd say, oh, I noticed that the common difference is going to be adding 3. So if I continue to add 3, I'll just go ahead and get my next number, which is 19. But here's the thing. With every arithmetic sequences, every arithmetic sequence, we do have an equation, where m is just the slope, or common difference. Write this down. And b is the starting value. Don't confuse that with the initial value. It's actually the zeroth term. Okay, so what does that mean? For this situation, what's the slope? Right? You could say, oh, the slope is going to be 3. So you'd say T of n equals 3n, where n is the term number, plus b. Now, if you said 3n plus 7, that would be incorrect. Watch this. You agree this is the first term, second term, third term, fourth term, and this one right here is the fifth term. What would happen if I plug in the number 5, or if I substitute the number 5 in for n? N, of course, meaning the term number, so term number 5. So if I said 3 times 5 plus 7, what would I get? 15 plus 7. 15 plus 7 is 22. Is the next number 22? You already know it's not. So this equation would be incorrect. Now, what is the correct equation? It's where the slope is 3 and the zeroth term, or the starting value, is the number, I'll go ahead and highlight it, it's the number before the initial value. It's the number before the first term. So we're talking about the zeroth term. Go back one step, subtract 3, and you'll see that the starting value, the y-intercept, so quote unquote, is going to be 4. Now, it's not a number that's on our list. We have to add it to our list. Well, we have to add it so that we can find out what our zeroth term is. So now this would be the correct equation for this example. Why does this matter? Many people on their quiz or test might say, oh, it's 3, the slope is 3, the starting value is 7. Well, we tried that. With the starting value of 7, it didn't give us the correct number. It gave us 22. What would happen if we do 3 times 5 plus 4. 15 plus 4. 15 plus 4 is 19, meaning this would be the correct equation. So it's a common mistake. We'll notice that the starting value is not the initial value. Our b is the number before it, which is the zeroth term. So that's a very, very key thing for these types of problems. Okay, we're going to go ahead and go over the next problems. So can you go ahead and check your work? If you've not done this yet, you can go ahead and follow along. We're going to go ahead and complete number 57 and also the back side of this page as well. So if you haven't tried it yet, you'd want to try that now. All right. It says consider the sequence -9, -5, -1, 3, 7 as you complete parts A through I. Now, first of all, is this arithmetic, geometric, or neither? If it's adding the same number every single time, you're going to say it's arithmetic, okay? Because it adds the same number every time. Now, what is the number that it adds every time? It's going to be difficult if it's negative numbers occasionally. For example, -1 to 3, it's not a difference of 2. It's actually a difference of 4. It's a little bit easier to see the difference when you look at the positive numbers. 3 to 7 is going to be that it's adding 4 every time. So you can say because it adds 4 every time, or we can be more specific and say it's arithmetic because there is a common what? Yeah, common difference, common slope, right, of 4. All right, next question, letter B. What is the first term of the sequence? Well, the first term is just the number that shows up first. Okay, so it is going to be -9. Letter C is a little bit confusing. I will be honest about that. It says, what is the sequence generator? The rule is just the equation. Okay, the rule is the equation. But the sequence generator, I guess you could say, it is that you have to add 9 to the previous, add 4 to the previous term. Okay, so if you notice, letter C and letter G do ask pretty much the same thing. If you're talking about the rule, you're talking about the equation. So if you wanted to add some words like you add 4 to the previous term, you can write that there. But for letter G, we're going to go ahead and write the equation. Another way to say equation is the rule. Okay. Now before we do letter G, I just wanted to make sure we have the table filled out correctly. N, remember, N is just the term number. So if we're looking at term number 1, the first term happens to be -9. The second term, third term, fourth term, fifth term, those numbers are already listed in our list here, so let's just write those down. -9, -5, -1, 3, and 7. Now, if we're adding 4 each time, what would be the zeroth term? What is -9 minus 4? -13. So what that tells us is this right here is our, what's it called? Yeah, our zeroth term, our starting value. So the slope for this one was going to be 4, and the starting value was -13. So 4n minus 13. Now for letter I, what if n is 0? How is this value represented in your sequence equation? So just really quickly, you know that you can plug in or substitute any number you want. Any what? Any number you want. We're talking about whole numbers though, let's be honest. We don't really have term number 7.5, but we do have term number 7. This equation, or this problem, asks us to just simply plug in the number 0 into the equation. Now, if I plug in the number 0, or substitute the number into this equation, what would it look like? That's all this question asks. It would look like this. Now, what would happen if I evaluated it? I would get negative 13. So t of 0 is negative 13. That is something that we already knew because it was in our table. Okay? So if you do graph this, it will be a little bit off the graph here. But it would not be numbers that you, it would not be a graph where you connect the dots because there is no such thing as a term number 0.5, 1.5, things like that. So remember that if you do graph this, it would be discrete, where it means you have just the dots. All right, let's go ahead and flip over to the back so we can go ahead and check our work for these problems right here. Now 58 is a very good problem. The next problem, 60, is a little bit more challenging, but for this one we're going to start off with number 58 here to check our work. Consider the sequence -4, -1, 2, 5. What is the zeroth term? All right, let's see what the pattern is. What are we adding each time? If it is consistent, we're adding 3 each time. Okay, so what is the zeroth term? The zeroth term is if we subtract 3. All right, what would happen if we subtract 3? What would be the number before that? So we can show some work here if we want to. -4 minus 3 would be t of 0 is -7. Okay, so if you said -7, that is the correct answer. What is the first term? The first term is, we can do a little bit of color coding if we want here. The first term is -4. What is the common difference? The common difference is that it's adding 3 each time, or you can just say 3. Check your work for this one. Write the equation for t of n. Verify that your equation is correct. So the correct equation would be, let me do the right color here, the slope of 3 and our zeroth term. Not our first term. We don't care about the first term for this equation. It's the number before it. So it'd be -7. Now let's just confirm. This one right here is our fourth term. So if we plug in the number 4, we should get the answer. 3 times 4 is 12. 12 minus 7 happens to be 5, which is correct. All right, you can go ahead and check by plugging in any of these term values, the term numbers, and seeing if the correct number pops out. That would be correct. Our next problem is it possible for the output to be 42? Now here is the thing. Of course, if you're using a calculator, you can go ahead and try this. -4 is our first term. If we keep adding 3, you can press equal, 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 equal. It will follow the pattern of adding 3. Will it ever reach the value of 42? It reaches 41, and it reaches 44. So you can say one reason is it will not reach 42 because it reaches 41 and 44, but not 42. There's a second way to do this. You can keep guessing and checking. If you know your equation is 3n minus 7, what would happen if you plugged in 10? Would you ever get 42? No, that wouldn't work. What would happen if you plugged in or substituted the value of 15? 45 minus 7? No, that wouldn't work. You can keep guessing and checking until you get the answer, but there is one sure way to get this every single time. If 42 is your output, your what? Your output, your expected output, then you should be able to solve for n. What is n? Your term number, right? Your term number. So if I was able to solve for n, and it's a whole number, then it would be possible. Let's see what number for n would it be. 49 divided by 3. We get 16.33. Now, is that a whole number? The answer is no. So you'd say not possible. With all of this justification we just did, the answer is not possible. And you can state your reason why. Was it that you guessed and checked? Or was it that you solved and you did not get a whole number? I'll write that one down. Not possible. N is not a whole number. And remember, n is just your term number. Okay. This method right here, I'll go ahead and give it a quick highlight. This method right here is very much a good way to check for any value. For example, would you want to keep pressing equals or plus until you get to, 50,000? No. You can just plug in that number into your equation. Okay, let's check number 5-60. Okay, you've already read this problem. 7 years ago, Cody found a box of old baseball cards in his garage. So right away, I'm going to go ahead and just write a table where it includes 7 years ago. Since then, he has added a consistent number of cards to the collection each year. Okay, so it's arithmetic. He had 52 cards in the collection after 3 years. Okay. And now has 108. So if you have a table like this is going to help you a ton. Because you can find out what the common difference is, and you can find out what the starting value is. Now, would you want to keep guessing and checking by adding 10, adding 10, adding 10, adding 10? Would that work? No. You could guess and check what the difference is, but do you remember this formula? Change in y over change in x. That's right. Change in y over change in x. If we do the change in y over change in x, we are going to get the slope. So really quickly, we can do the change in y. This is our y value. (108 minus 52).
It's 56.
We get a change of 56 and the change in x. 7 minus 3.
The answer is 4.
All right, so we're going to get 56 over 4. What is 56 divided by 4?
It's 14.
We're going to get a slope of 14. All right, so that is going to help us solve and answer these questions right here. If the slope is 14, we know we can get the next numbers after this. It's going to be an addition of 14, so that would be 66. An addition of 14 would be 80, 94, and 108. Now if we go backwards, we can get all the values in our table. 52 minus 14.
The answer is 38.
38 minus 14.
The answer is 24.
24 minus 14.
It's 10.
We get this important table. Remember, the values that are so important in this table are the y-intercept, the starting value, or in this case, the zeroth term. And secondly, the most important part of your equation is your slope. All right, so since we know the slope is 14 and the starting value is 10, we can come up with an equation right away. So really quickly before we write down that equation, let's see if we can answer letter A. How many cards were in the original box? Is that T0 or T1? 20 is the correct answer. That is his starting number, his first box that he opened. After 1 year, he had 24. After the next year, he had 38, etc., etc. Letter B, Cody plans to keep the collection for a long time. How many cards will the collection contain years from now? Well, we'll leave this one blank because this question does not ask us how many years, so we can come back to it. Otherwise, you can say he's not going to have many because he is only adding 14 every time. It's a very slow, and in this case, for baseball cards, it would be technically a slow collection. Okay, letter C. Write an equation that determines the number of cards after years. What does each number represent? Okay, so we got the slope of 14 and the starting value, zeroth term of 10. Okay, so let's just go ahead and point out a couple things here. The n is the term number, or in this case, year. 14, that's going to be your slope, your change, your common difference. And 10 would be the zeroth term, or in this case, the starting amount of cards in his collection. Okay, that is where we're going to stop. I want you to make sure you have 64, at least trying one of those, seeing if you can get the correct answer. Remember, slope is change in y over change in x. Once you find that, you can get your slope. Okay, really quickly, let's just do the start of this one. It'll be 54 minus 10 is 44. 7 minus 3 is 4. 44 divided by 4 is 11. So we can say T of n equals 11n plus b. Do we know what the starting value is, or the zeroth term? No, you can find it out by subtraction, or you can find it out by solving. Now, really quickly, we could solve by putting these numbers in. So 10 would go here, 3 would go here, and you can solve for b. Since we're here, we can do this pretty quickly. We're going to go ahead and subtract 33 to both sides. That gives us b is negative 22. So the equation would be 11n minus 22. If you follow those steps just like we did with linear equations, you can go ahead and find out the slope and starting value of any function given two terms. All right, that's it for now. We're going to stop here. Hope you have a great rest of your day and great rest of your class.